there is a rule of thumb, and it's only that. It's not a hard, fast rule. This is not like some law of statistics. It's just a rule of thumb. At least for now. There will be something that happens later on that makes this more of a rigid law. But for now, it's a rule of thumb that helps us use a standard deviation to visualize a distribution. And it's pretty simple. There's just 2 points. The first point says that if you know what the mean and the standard deviation are for a set of data, so if you've worked at the mean and the standard deviation, you can expect that around 70% of your data will fall within one standard deviation of the mean. So what that means is, if I had a distribution that, let's say my distribution looks like this, and I have my central tendency, I've got my mean, and the mean was equals to, I don't know, 50. And I know that the standard deviation is equals to 10, for example. 70% of my data should fall within one standard deviation of the mean. That means that as long as I'm within about 10 of this 50, I should see most of my data falling within that space. So it's going to end up being something like over here. This is going to be the mean plus one standard deviation. So I'm one standard deviation above the mean. And if I go down an equivalent amount below the mean, so this would be one standard deviation below the mean, so it would be the mean minus the standard deviation. If I do that, if I can figure out what my mean is and what my standard deviation is, then I could say that around 70% of my data, of my observations, fall between those two values. The mean minus the standard deviation, so 50 minus 10 would be 40. And the upper limit here would be 50 plus the standard deviation, so 50 plus 10, it's going to be 60. So 70% of my data should be between those 2 points. Now the real power of this is you don't have to draw it to be able to say that. The rule of thumb takes care of this for you. If you know that you have a distribution with a mean of 50 and a standard deviation of 10, you can say with some certainty that most of your data, a little bit more than 2/3, should fall within one standard deviation of the mean. This tells us that a standard deviation accounts for most of the variation that you'll find in a population. Most data points are going to be different from the mean, but they're not going to be that different. Most of them will be clustered close to the mean. So they're not going to be exactly equals to the mean, but they will be close. They'll be within about one standard deviation. Beyond that, you can expect that around 95%, so that's almost all, of your data falls within 2 standard deviations of the mean. So if I was, once again, to have, have that distribution drawn, and most of my data fell within one standard deviation of the mean, or about 70% fell within one standard deviation, then almost all of my data would be covered if I didn't just go away, or if I didn't just measure within one standard deviation, but if in fact I went 2 standard deviations. Almost all of the data. There's really not much of anything left over after that. This is 95% of my data falls within 2 standard deviations. So if the mean is there, this would be the mean plus 2 standard deviations. This would be the mean minus 2 standard deviations. So the real power of this, though, is not drawing it out right now. We're going to get into these sorts of diagrams or these sorts of analyses later on in the course. Right now, you just need the rule of thumb. You just need to know that we're going to have our data follow these rules generally. So let's go through an example so I can show you this sort of a thing in action and show you how closely just a simple data set will follow these rules here. All right, so let me clear this out, and I'll just go down a bit. Okay, so let's say I've got, actually let's make that a little bit easier to see. All right, I've got a data set here that I just chose online. I just quickly found. I didn't want to work too hard to try and make this fit, because the whole point was that these rules of thumb are supposed to apply to most data sets that you see. And so I think this was just the first one that I found when I went looking for just a random data set, and it works out well. So let's have a look at this. It doesn't work out perfectly, but it's not supposed to. So I've got my data set here. I don't know what the mean is yet, and I don't know what the standard deviation is, but previous videos I've shown you how to do that. The mean is just equals to the sum of x, so I just have to add these up, divided by, I'm going to treat this as a population. And so I need to know what n is, I need to know what the sum of x is. Now n is very easy. I just have to count 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 data points, and sum of x. I have to add this up. Okay, so if you add up these values here, you'll find that the sum is 32. So I've got 32 divided by 8. This comes out to be 32 divided by 8. That's 4. So our mean is 4. So what we should find is that 70% of our data falls within one standard deviation of 4, and 95% of our data falls within 2 standard deviations of 4. But we don't yet know what a standard deviation is. To find a standard deviation, we have to go through a bunch of steps. First, we find our sum of squares, which is the sum of the squared deviations from the mean. And then we can find the variance. The variance is the sum of squares over n. Remember, I'm treating everything as a population here. And then finally, the standard deviation is going to be the root of the variance. So let's start at the beginning here. I need to find my deviations. So I need to take each value and subtract the mean, which is 4. So 4 minus 4 is 0. 5 minus 4 is 1. And these are the same. 2 minus 4 is negative 2. 6 minus 4 is positive 2. So these are my deviations, and you can check to see that these actually add up to 0, as they should. They always add up to 0 in this column. We then square them, and so that's going to take care of the next part of this formula. So we square them. 0 squared is 0, 1 squared is 1. 2, whether it's negative or positive, 2 squared is a 4. And when I add these ones up, then I get my sum of my squared deviations. And that one comes out to be 2 plus 12 is 14. So my sum of squares is equals to 14. So now I can work out the variance. The variance is going to be 14 over n. I know that n is equals to 8. And this comes out to be 1.75. So I've got my variance. Now I just need to take the root of 1.75. And that one comes out to be 1.3228. Although I think I'm just going to round that, make it simple. I'm just going to call it 1.3. Again, this is not a hard rule. This is just a really simple rule of thumb. Okay, so now we do have everything we need. We know that the mean is 4 and the standard deviation is 1.3. What I should find is that 70% of my scores, according to my rule, let's go back up and have a look at the rule, 70% of my data falls within 1 standard deviation of the mean. So that means that if I did the mean minus a standard deviation, and I went all the way up to the mean plus 1 standard deviation, so I'll just put a 1 in there to make that obvious, I should find 70% of my observations fall within this range. So the mean is 4 minus 1 standard deviation. That's not very easy to see there. Let's get rid of that. The mean minus 1 standard deviation, and this is the mean plus 1 standard deviation. So 4 minus 1.3, what's that? That's 2.7. And the upper range is going to be 4 plus 1.3, so that's going to be 5.3. So how many of my scores are between 2.7 and 5.3? Well, this is between 2.7 and 5.3, so is this, so is this. This is not, and this is not. So I have 1, 2, 3, 4, 5. 5 out of 8. And 5 out of 8 is how much? Let's check this out. 5 divided by 8 is 0.625. As a percentage, that is 62.5% of my data falls within 1 standard deviation of the mean. It's not exactly 70%, but it's in the right ballpark. So what we should find when we go to the next standard deviation is that almost all, if not all of my data, so 95% of the data falls within 2 standard deviations of the mean. So what would that be? That's going to be 95% between 2 standard deviations above and 2 standard deviations below the mean. This is a 4. This is minus 2 times 1.3, so that's 2.6. So 4 minus 2.6 is what? 1.4. So from 1.4 all the way up to 4 plus 2.6. 2 times 1.3 is 2.6. So that's going to be 6.6. Well, how many of my scores are between 1.4 and 6.6? This is, and these are, and this is, and this is. So I get 100% of my scores. So the rule of thumb says that it should be 70% and 95%. We got close to 70% here, 62.5, and close to 95% here. It's just a rule of thumb. It's just to help you visualize what's going on with the data. You're just supposed to be seeing that the majority of the data is close within 1 standard deviation, and almost all of the data, maybe there might be a few exceptions, are within 2 standard deviations of the mean. And that's it. As I mentioned earlier on, this rule of thumb is going to become a lot more fleshed out later on in the course when we get to something called z-scores and z-tables and the normal distribution. For now, it just gives us 2 general points that we can mostly count on when we're dealing with data sets.